Hello, welcome back to the radio room. We're resuming with the FP1023 Yaesu power supply that is not working. Last video did some testing, did find a couple of resistors that were out of tolerance. They had nothing to do with it working or not. Mostly just bleeder resistors for the two big filter caps. Had a little snafu with the videoing on the last video, so a lot of the work that I did didn't get recorded, or at least recorded properly. So I figured I'd give you a real quick rundown of what I have done. At this point, we're still not working. So I started going through and checking components on the board. I basically checked all the diodes and resistors in this area. I've also pulled the two transistors off, NPN transistor, switching transistors off, and tested them out of circuit, so there wasn't any interference. They showed fine on doing the diode test for transistors. The same as on the rectifier, the diode bridge right here for the output voltage. I also pulled these capacitors off and tested them. They're fine. These are the main output filter capacitors for the 13.8 volts. They're good. They look good. They test good. They're not shorted or anything like that. So I think we're good on those. I also pulled out the two transistors right down in here, which, let me amend a little bit of something I had in the previous video. I was saying that the pulse width controller controlled these. It does, but not directly. It actually controls these two, which are connected to this circuitry over here through this transformer, which then controls the switching here, which after it comes out of there, of course, it goes through the transformer, through the rectifier, and basically to the output with some feedback going to the pulse width after it comes out of the bridge, right before the filtering, which the filtering would still filter that. It's all parallel. So basically, I've tested just about everything, every component in here. Everything seems like it tests good, but we still don't have any VCC coming over here. To tell you the truth, after all the testing I've done, the way this power supply should work is you've got to have VCC obviously going to here to make this work. Well, where do you get that voltage? If you just turn it on and this ain't working, how do you get any output? In this stage right here, and let me go ahead and pull the schematic up, and we'll take a look at this just a little bit closer. If you take a look on the schematic, let me zoom in just a little bit here. So right here is the IC that's got to have the VCC. In fact, the IC, the VCC is right there, which comes from basically right here. This is VCC 24 volts right here. Also has sends some 24 volts over here, but this is the charging capacitor right here. This is also the charging voltage for C13. So it's got to charge this, and also you get some VCC over here. So these right, whoops, let me get my pointer here. Right here are those two big transistors, which do the main switching for the main output. Right here is another set of transistors. What they're doing is they're actually controlled by the IC, and they start pulsing basically right here, which starts turning these right here on and off. In this circuitry right here, we have a little bit of resonance. There's actually, looks like right here, Looks like you actually would have a little bit of resonance going right here. That would have a time delay, and then of course, when things this capacitor charges up and discharges back through here, it would control. Let me get this out of the way. It could control this base right here, and same thing on this one right here. Because if you look on the bigger scope of things here, we actually have, if you look at this right here, coming off of here is our line voltage. And it's going up here and it goes through right here. So it's going to send it up there and go and actually start tying into this here. The neutral side, there we go. On the neutral side of things, we do have this going up to right here and actually comes all the way back around and connects back to here. So there is some voltage that can flow. It's actually rectified, it looks like, probably right in here. Between that and this, and these circuits right here, you could probably get a little bit of resonance right in this area. Which, let's call, for lack of a better term, the starting resonance. So this IC runs from anywhere between 7 and 40 volts that you can put into the VCC. But it needs, I'm going to say that 7's probably pretty close to minimum, because inside of this IC there's actually a little bit of a regulator. This IC actually runs on 5 volts. But it has an internal regulator in it that can take 7 up to 40 volts and regulate it down to 5. So I'm kind of curious if we shouldn't get on the output, even with this not in the equation, this, I'm wondering, should possibly generate, of course, this is switching here, which is going to start controlling the, sending pulses through this transformer to the output portion that's right here. I'm wondering if we can get somewhere between 5 and 7 volts over here that controls this to start it. It's not the actual output, but I'm wondering if there's a resonance circuit right in here that gets this alternating across this transformer enough to get 5 to 7 volts out of the output, which feeds back over right here. See this right here? Following this line across, which goes to VCC. I wonder if I'm thinking that's probably where it gets the minimum of 5, because this is going to be regulating. So if that's got a regulator in there, it's probably got just in and of itself probably a half a volt drop on it. So you'd probably need at least a half a volt higher. That's probably why the 7. It gives it a little bit of overhead there. I'm kind of wondering if our chip is bad. And maybe something is shorted inside of here, which is dragging down our voltage and not letting it start. For one, the chip's bad. It's not going to start anyhow. But there might be a short in here coming from the maybe on the VCC that's pulling down this voltage and shorting it, possibly, out through the ground or something, which is right there. And that's why we don't read a VCC. Maybe this is trying to generate a starting VCC to kick this going and make it start, which would, of course, build us up to 13.8 after it's keeping itself regulated right. But if this is dragging it down, we might not see it. So here's what my plan is. I'm going to take the chip out. And after I've pulled it out, I'm going to see if we get any voltage, which should be out to there. Maybe 5, 6, 7 volts, which would be that that starting voltage to turn the IC on, get it going, start it, so to speak, which would then start controlling these, which would start sending pulses through here, which is going to control these here, which is taking the very high voltage and switching it through here, which is stepping it down to get our actual voltage. So my plan is let's take the chip out. So, like I said, I've tested just about everything on this board. I cannot find any component that's wrong. The only thing that I haven't checked, and it's hard to check unless you build some sort of rigging or something, is the actual chip. So I'm wondering if the chip is bad. So I think our plan should be, let's take the chip out, let's turn it on, see if we get some sort of starting voltage right in this area. We'll measure that over here on the output, or at least at the cathode of the output bridge or rectifier. There's actually D10 down here. We could check it off of as well. If that's the case and we do have voltage afterwards, I think it's time to order a chip and change the chip and see if that works. That's the next step I have. And hopefully we get the voltage and we change the chip. And I'm just about to the point on this thing. After all the stuff I've pulled off this board and put back on this board and checked, even if we don't get voltage here, and maybe I'm wrong on that starting voltage, maybe this doesn't have like a little bit of a resonance here, which kind of starts these to making some output. I'm still thinking it's time to, we'll put a new chip in there anyhow, which I'll have to order, and of course I'll have to wait a week or so to get it in. But that's my next step, is pull this out and see if we get a voltage. I'm thinking it's going to be, if we do, it's going to be somewhere between, say, 5.5 and 7 volts. But I think that might be the problem, is this might have a short in it, or some sort of malfunction in it that is basically pulling whatever voltage I'm suspecting is coming out of here down to the point where we can't register it with this in circuit. So I'm going to pause, going to get the soldering iron and the solder sucker, desoldering gun heated up, and we're going to pull that puppy out. Okay, so everything's heated up and we are ready to take this IC out and see if this idea is going to work. So it's going to be right here. Just a second, I want to make sure I can see this clearly. Alright, let's try this. Add a little solder to the end of my, kind of tin the tip of my deal here. It's getting a little dry. Okay, hopefully that got them all free. Let's check. Nope, looks like the chip is loose. Might have bent the legs just a little bit when they put it in there to hold it in there, so it might catch a little bit. Let me help it out a little bit here. Catching on the holes right now, so let me help it out a little bit. Looks like we got a pin down here that's catching. Okay, that one's out. And just for future reference, we're gonna make note that the little half moon cutout, which designates one end of the chip from the other, since it's basically just a symmetrical chip, is towards this way. But if this is bad, we're going to be putting a new one into it anyhow. And like I said, I'm kind of suspecting that that is bad. So, I'm going to flip this over, because when we do our testing, I might test to the VCC pin, which will be, we got 1 through 8 here, so 9, 10, 11, 12. So 1, 2, 3, 1 through 8 here, 9, 10, 11, 12 should be right there. So I want to test right there, see if there's voltage there as well. But we'll see if there's any voltage on the output between here and here. This is the output. So let me double check, make sure everybody is in a good position to try this. The switch is off. Cord is plugged in. It's plugged in here. Go ahead and get my DMM down here so we can check this. And let's turn it on and check to see if we have any voltage right here. Not much. Very little. But I'm still going to check it right here. So maybe that plan did not work. But I'm still kind of thinking that the problem might be the chip. I think I'm probably just going to go ahead and order a new one, and we'll see if that'll fix anything. Other than that, like I said, I've checked just about everything on this thing just to see if we actually had anything coming out. So. And we still do have high voltage coming out of the rectifier, so we just still do have voltage. So I'm kind of thinking that might be the problem, but I think that's what we're going to go with from here, is just see if we get anything. I mean, I'm not getting anything there. So we could still have a problem in here. Maybe this isn't starting right here. Give it enough. I mean, you got to have some voltage to turn that on to begin with. That's the theory I'm working off of. So I think that's where we're at. I think it's get a new chip and put that in and see if things start up then, because I have checked just about everything else in this area over here, unless there's something up with one of the transformers. That's the only other thing I can think of. Possibly this thermistor, this thermal switch that's up here. I'm also kind of suspecting, but, and the reason for that is that I measured across it and I was getting about 14,000 ohms. It says normally closed on the schematic, but what they're calling closed, I'm not sure exactly. I don't know if it should be 0 ohms. Before, when I was testing things before, I did jumper across it. This is basically a thermal protection. If this transformer gets too hot, this switch, from what the schematic says, will open up and shut the supply down. So it says normally closed, so I actually jumpered over it, and it still did not come on. So I don't know. That could be a problem. But I'm thinking having a new chip isn't going to hurt anything. They're like a buck. I mean, the shipping's probably more than the chip itself. So we'll check that out. But that's where we're at on this. I think it's kind of going to be a wait and see if we can get the chip in and see if that does anything. In the meantime, I might probe around here a little bit more, check some things, but I'm pretty sure I've checked just about every component in here. I know it's not in the high voltage side. It's got to be over here in the switching stuff. So we'll go from there. And I did pull out these transistors that are the first step of switching. They tested fine. These tested fine. I'm not seeing anything else that should be a problem. Unless, I mean, obviously I could just be missing something. But we'll go from there. Get that ordered. Might order another one of these just in case. And put it back together and see if it works then. That's about where I'm at on this. It's definitely being an elusive problem. I'm sure there might be somebody out there watching going, no, it's right there. Well, I'd appreciate that in the comments. But other than that, we'll just go ahead and kind of put a hold on this project. Okay, so I just ended that video, but I'm going to tag this on the end of it. I was going back through this and was like, you know what? I'm just going to check everything again. And I think I might have missed something. Before I get too nuts here with moving things around, I'm going to unplug that. So I was going back and I was checking the resistors and diodes, like I had mentioned before, along this area. You'll notice I've got something new in there. In fact, I'm going to trim this back just a touch. I was going through and checking the resistors again, and I came to this one. And it's supposed to be a 270K resistor, and I couldn't get anything on it. Or it was very intermittent, it seemed like. So I pulled it out, just to make sure everything was, I wasn't getting a bad reading from something else. And I am in, so I got to go above 200K in order to do a 270. So I'm in my top reading. So just shouldn't show you its reading. So there's shorted out. We got 0. I get nothing there. And that's 2000K. So that's 2 megohm. So this has a higher than 2 megohm resistance. Kind of like that other one we found earlier, huh? So I once again, I guess Samlex decides to choose odd values that I'm not going to have, I guess. This is a 270K ohm resistor, half watt. I did not have anything in my half watt resistors that would conveniently, for one, I didn't have 270K. 2, I didn't have anything that wasn't going to be a blob of resistors put together to make 270K. Whether I was doing parallels or parallels or series resistance ones, I might end up with like 3 or 4 resistors. So I went up to the 1 watt resistors. At that point, I did have 2 of them. I got a 200. Now this is a plus or minus 5%. So just real quickly, 270 plus or minus around 200 and what would that be, 56 or something K would be the bottom end, and like 284 or 5 would be the top end. Well, I had a 220K and a 47K. That gives me 267K resistance. That's within 5%. That's actually pretty darn close. So I went ahead and put those in. And now is the test. Let's go back to what I was saying just a few minutes ago, because this is in what I was calling the resonance circuit to start, the starting resonance, in order to get some voltage. So the power supply, I still have the chip out. But what I'm going to do is I'm going to do the same test we just did a minute ago, since I found something over here. Well, is this going to have enough starting resonance to maybe get something between 5.5 to maybe a little over 7 volts on our output that could maybe be used as that VCC to start the chip? So I'm going to plug it back in. We're going to start it up. It might run a little funny because it's not going to go straight from having that voltage and then starting. So I'm expecting it might actually make some noise because I have a feeling if these are switching in order to get that starting voltage, which normally probably happens like that, and then it's over here and it's being regulated, it's probably going to be like a 60 hertz, 120 hertz, probably a 60 hertz cycle that's generating that, which that's an awfully small transformer for 60 hertz. So it might make a little noise. I'm not sure. It might buzz a little bit or something. And then we'll, if this works, we'll put this back in and see if the power supply works at 13.8 volts. So double checking, making sure everything looks good. I'm going to go ahead and plug it in. Got the switch off. And since I don't want to leave this on any longer than I have to, I'm going to see if I can get these to just clip to the output here. So if we see voltage, we'll shut it back off, and then we'll put the chip back in and see if it's regulating at 13.8. If it's not, we might still need a new chip. Or maybe I'm going to blow something up again and we'll have to start over again. Let me see if I can get this to actually clip on here somewhere. It's got this blob of solder on here, which I'm going to have to clean off before we put this thing back together. That doesn't want to let my clips, they're sliding off, for lack of a better term. So I'm just going to stick that right there like that. Everything looks good. So let's watch the meter. Let's make sure you guys can see the meter without any glare. Okay, I'm in the 20 volt section. I'm going to turn it on, and hopefully we're going to see something between, I want to guess somewhere between 5.5, maybe just a little over 7 volts, because we need at least 7 to start the chip if it were in there. So, oh, we have some voltage. It's coming up. It's above 5, still climbing. 7 volts, still climbing. So I'm going to go ahead and shut this off. And yes, it is making a noise, and it does sound like it's coming from the transformer. Hearing the switching, because like I said, this is not a normal 60 hertz transformer. Needs a lot more mass to it to be efficient. So it's probably losing some efficiency in being such a small core. So I'm going to go ahead and undo this, have the switch off. I'm going to unplug it, and I'm going to put the chip back in and see if this thing might actually work. So here's the chip, and I am going to carefully straighten some of these legs out just a little bit, so maybe it'll go in a little bit easier. And I might have to kind of walk it in there a little bit. I don't know if it's just going to slip right in there or not. Okay, so I do have the tiny little half moon, and we decided that was that way. Hopefully these legs are lined up close enough I can at least get them started into the holes. So let's see here. Kind of got that side started. Now I got to get the other side started. And I might have to kind of just walk it down the row here. Yeah, it's trying. It's about the hardest part about trying to put a removed IC back in. I think I got one side a little too high. This one, I think I actually got to get this one cleaned off a little bit better, because those holes are very tight to begin with. Oh, now it doesn't want to come back out. Okay, let me see here. Alright, I might have to get the desoldering gun kind of heated back up. I think I got a little too much solder still left on this one leg here. Unless I can get it started on the other side. But I think it's just got just a touch too much solder there to want to go down in the hole. Yeah, it's rocking on that one. Even when I try that side. So I'll get it cleaned up a little bit on that one leg. And hopefully once we get this thing back in here, we might have a power supply that's working. If the gun ever heats up. Okay, let's see if we can get this in here now. Make sure we're in the right direction. I'm going to go ahead and see if I can't start this side. Because this is not going to be easy trying to get these back through these tiny little holes that are just barely big enough to do this. Especially since the legs have just a little bit of a bend to them right at the end. It's trying. Okay, I got it back down through the holes now. See if we can get this thing soldered in. I need just a little more heat on it. I turned the soldering iron down earlier. Alright, let me check the solder joints real quick. Okay, they look pretty good. I'll let that chip cool down just a little bit before we turn anything on. And we will see if this thing is going to work. Fingers crossed. Or see if it goes up in smoke. Well, I hope not. Okay, so plugging it in. Let's turn it on. Look at that. 13.8 volts, moving around just a little bit. Let's kind of moving around on voltage a little bit. I run my finger over it and I think it's the capacitance to me, and I can actually hear it ring. And it changes the voltage just a little bit, so it probably changes the time constant just some. But I'm going to think that that is, I think we got a winner. We got 13.8 volts. Roughly. Of course, the scan rate, of course, we'll get it back into the container and make sure everything is working good then, too. I don't want to leave this on too long without things heat sinked down to the chassis the way they were before. But I think we got a working power supply. Of all the things I checked, I guess I missed that one. And I thought I'd went through that one. But of course, that one's also tied to another capacitor, so I might have checked it and went, yeah, it's high or something. Maybe I looked at it wrong and saying, well, maybe it's that capacitor, and then pulled the capacitor. Capacitor checked okay, and never went back to check to see if the this tiny little resistor was the problem. So really, all in all, and there's another one around here somewhere. We put 3 resistors in this thing, and it looks like it's probably going to work. Once we get it back in there, I might try to see if we can put just a little bit of a load on it and see what it does. Make sure it stays regulating. Otherwise, this one I think would be the only problem after that. Anyhow, but I think we're going to be pretty successful on this. So I'm just going to pause. I'm going to put everything back together. I am going to clean these up a little bit. Just to, well, I can still feel the voltage just a little bit on that. Is there some voltage on that? No. Might have just been my finger running over a rough spot or something. I'm going to clean these up so I can solder them back in better. And I'm going to get it all back in the case, and then we'll test it, make sure the fan comes on and everything. So just give me just a few minutes. Okay, so I've got the power supply board mounted back in. It's back to being heat sink down to this heat sink. Got the connectors resoldered in here. That was just loads of fun. But I think they're going to be just fine. They seem to be soldered pretty good or making contact very well. I got the connector put back in, the ground wire hooked back up. It's I think really just ready to turn it back on, make sure it's still working, and I think it's going to be done. So let's go ahead and I got it plugged in. Let's go ahead and turn it on, and let's watch the voltage. And 14 volts with no load on it. I don't know if I really got anything necessarily handy right now to put a decent load on it, but I think that's a good sign. I think it's going to regulate okay. I'm trying to see if I got anything that I can just hook up to it real quick. I never have anything just ready to hook up to anything, but I really need to build an actual load sometime for this for testing power supplies. You'll notice the fan's not working. I did look up in the manual. That doesn't come on until the temperature of this transformer gets up to 70 degrees Celsius. So unless it's got a decent load on it, the fan's not going to come on. It just convection cools. It's got slots, on the side of the, so it gets a little air moving through it anyhow. But I think we're good to go on this, and I think it's back to working all right. Just needed a few resistors put into it, and seems to be working pretty good. Nothing seems to be getting hot right now. Of course, there's no load on it right now, so yeah, everything seems to be staying cool. So I'm going to call it a win, and we'll get it back to its owner, and he can continue using it. So this time, thank you for stopping by the radio room and finishing out this power supply with me. I'm going to wipe it down real good, make sure it's cleaned up and nicely, and get the case back on of it and get it back to its owner. So we'll see you next time.